So you should have the PowerPoint up if you're directly in front of me. You are with somebody. I want you to take a look at this, and I'm timing you. You have 2 minutes. I'm going to press pause on the video. 2 minutes working with your partner to come up with what you believe the correct answer is. Please begin. So how can we go about doing this question? So we're going to write base 10 with the log. So on your paper, please write base 10 with the log. Now, if 100 is here, let's think about this. What does this mean? It means 10 raised to what value equals 100? 10 raised to what equals 100? The answer is 2. So this is a 2 at this position. Now, if we think about 1,000, 10 raised to what value equals 1,000? The answer is 3. And this is directly in between. So guess what that value would be over here? It would be directly in between 2 and 3, which would be 2. You have for this problem 90 seconds. Begin. Call me over when you believe you know it. I would be writing something on paper. This is not a one really you can probably do in your head. If you are watching this remotely, please find the inverse of this equation. Okay, let's look at this together. So I took this general equation, y equals log base 2 of x, and now I'm going to find the inverse. So to find the inverse, remember, algebraically means we're going to switch the x and y. So I'm going to write x equals log base 2 of y. And now I need to isolate the y. So how do I remove the log base 2? I take whatever the base is and I put it on the bottom of both the left and right. Base exponent, base and exponent. Okay, that simplifies to 1, and now I have y equals 2 to the x. Now y, remember, is really like f of x, and this is the inverse. This is the inverse of x. So this is the function that's inverse, and this says if g of x is the inverse, so this is g of x and it equals 8. So my question is, what does x equal to make this a true statement? The answer is 3. 2 times 2 times 2, 3 times is. Let's talk through this together. Just curious here, can you raise your hand right now if you think, I'm not going to ask you, if you think you know the answer, a potential answer, hands up high. Potential answer. Okay, so when we think of this, let's go back to what it says. The criteria says that we are talking about the time in studying and then the results and the score. It says, the class observed that when study time doubles, the test scores increase by 5 points. So let's just come up with an example here. Let's say you study for 10 minutes. I'm just going to make that up. And let's say your score is a 60. Now, if you double that study time, you'd be up to now, doubling is what? 20, but your score would only be at, now if you double again, you'd be at 40 minutes and up to 70. If you double again, you'd be up to 80 minutes and you'd be up to 75. Can I have a thumbs up or thumbs down? Please make sure right now all earbuds are out, all cell phones are put away. Can I have a thumbs up or thumbs down if this criteria makes sense to you based on what I just read? Okay, so here's what you need to know. Please write this down. With log functions or natural log functions, when the y values increase linearly, like when the y values go up specifically by adding or subtracting, a specific amount. So we're like adding 5, adding 5, adding 5. When that's the case, and when the x values go up and they are being multiplied, okay, and so this time they're being doubled. We're doubling, the rate is doubling each time. We're doubling the previous amount. When that occurs, we are looking at a log function. We are looking at a log function. Now, if I was going to reverse this, watch this. If I flipped this and if I told you that the x values go up by adding or subtracting specifically the exact same amount, and if the y values or the outcomes are in this case doubled or tripled, right, consistently, then it'd be exponential, because exponential and log functions are inverses of one another. okay? So this is an example right now of a log function. Let's analyze right now. Let's analyze. So I'm going to start right now because it's very easy to see the outcomes. How am I going from one outcome to the next? What am I doing? I'm consistently doing what? Adding the exact same. So there's a common difference here. Now when I look up above at the x values or the input values, how am I getting from 2 to 4? Somebody could say, well, you're adding 2. That's true. But we have to do the same thing. In this case, we are multiplying by 2, multiplying by 2, multiplying by 2. So this is another example of a what? Of a logarithmic function. Now remember, if this was flipped and you were adding or subtracting on top, and then on the bottom you were multiplying or such, then it would be exponential. So now I'm looking down below at these two, but you have to know the reasoning. So I have a 50% chance of getting this right. And in this case, the correct answer is the function f represents a log growth because the input values change by multiplying and the output values change. As a quick reminder before you try to do this, if you are watching this video instead of being in real time, I want to remind you that if I gave you two functions, and let's just make up two different functions. We have p of x and we have q of x. And if I said algebraically, I want to prove that these two functions, p and q, separate for this problem for a second, are inverses of one another. If you took p of q of x and it equaled x, and then if you took q of p of x, so we're using composite function and it equals x, it means these two are inverses of one another. Now graphically, what does it mean if they're inverses of one another? It's a couple different things. If we took p of x, and this is what we had, and then we took q of x, and this is what we had, who can tell me what happens to the inputs and the outputs? They switch. So the inputs become the outputs, and the outputs become the inputs. Now graphically, there's an even better way that's going to add to this. Graphically, if I graph them, and I'm just going to make this up, if I graph them, let's just say this is p of x. I'm making this up. This is p of x like this. And if I had to do a rough graph of what this looks like for q of x, I would go to the line y equals x every single time. By the way, look at this, y equals x. See the relationship here? Y equals x. And I would act like I'm folding along that line. And if I was able to fold along the line y equals x, it would look like this. And this would be q of x. Does everybody see that? Okay, use that given information. I'm going to press pause, and with your partner, I want you to identify the correct answer. How would I do this? Again, if you were live with me, I explained to the class, like for 5 minutes, I read this question. I was like, how am I going to determine what g of x looks like, and then to be able to determine this? I had no idea. Then I went back and I read through it slowly, and I recognized that this is telling me, without actually putting it into words, that g and f are inverses of one another. So I can go here to y equals x and draw the dotted line, and then if I'm going to do the inverse of this, it's looking like this. So if I'm folding, it's looking like this. So what is this? One is it's increasing. So anything that's not increasing, I cross out. That's a test-taking tip. We have a 50% chance of getting this right. Is this concave up or concave down? We know that it is concave up. All right. So in this function, by the way, real quick, I know A and B. I know A and B really quickly are going to be positive values. A and B are going to be positive values. Did everybody hear that? And by the way, so A, when we think about this, it's going to be, if I come over here, A and B, and here's the horizontal axis is in standard form. That's standard, standard, standard. Okay, perfect. Then it says the vertical axis is logarithmic. Logarithmic means we're going up by a multiplier. Do you see how this looks pretty standard? 1, 2, 3, nope. Oh, here we go. We're going up by a multiplier. Okay, going up by a multiplier, going up by a multiplier. Okay, all of that looks good. What am I able to do next? Well, the next thing is, if I'm telling you that if we came straight down here, did you guys see this? What is my starting value? 1. Is that a positive value? Yeah, that's my initial value. And I'm telling you that this is going to be a positive value, so anything greater than 0. Here, does this even have a starting value? No, it doesn't even cross. Does this even have a starting value? Doesn't even cross. There's my correct answer. Where it crosses the y-axis is your starting value. And here it doesn't even cross the y-axis. Here, when we're looking at 0, it doesn't even cross the y-axis. So if I know that this is f of x and I want to get the inverse, can you tell me 2 points that are going to be the inverse points? 0, 1, awesome, and 1, 4. Why is that? Because the inputs and the outputs just switch. So I'm going to write down y equals ab to the x. So I'm plugging in an output of 1 and an input value of 0. By the way, b to the 0 is what? What is b to the 0? 1. So this is just 1. What does a equal? 1. I know a equals 1. Okay, got it. Now I'm going to do the second one. So my output is 4, and my input value is 1. But I also already know that a is 1, so I have 4 equals 1 times b to the first. Well, dividing by 1 doesn't change anything. I have 4 equals b to the first, or 4 equals b. So I'm going to rewrite this equation. Y equals 1 times 4 to the x. This is my inverse equation. So now I just need to find out which one of these lies on it. So if I plug in an input of 2, 4 squared is 16. 16 times 1 is 16, not 8. 4 squared, yes, this is an example of logarithmic, and inverse of logarithmic is exponential. That's what we're looking at here. 4 squared is 16. 16 times 1 is 16. Correct answer is B. The properties of function f states that each time the output increases by 4, okay, each time it goes up by 4. So I'm just going to start with a number. I'm just going to make it up. It increases by 4. So I'd have 3 plus 4 is 7, plus 4 is 11, plus 4 is 15. And then the corresponding input value is going to be multiplied by 4. I'm going to just make this up. So if this is 5, it's multiplied by 4, times 4, times 4, times 4 is that 320? So right now, turn to your partner. Does this data, doesn't mean it matches this graph, but does this data represent right now exponential or logarithmic, and why? Turn to your partner. What does it represent? It's logarithmic. Why? Because the output is increasing by adding and the input is increasing by multiplying. So which two right now can I cancel out right away? Anybody? I can cancel out this one and I can cancel out this one. Do you guys agree? Okay. Now, the larger the multiplier is, the faster the function rises. So just based on that fact, which one do you think it is? The top or the bottom? The bottom. This is like our parent function. So in this particular problem, I'm working at the log. So remember, a basic log function is looking like this. Basic log function. Now this says we're going to take this function and we're going to move it up 1. So we're shifting up 1, okay? And this says we're going to reflect it across the x-axis. And then notice, by the way, after we reflected it across, that the 3, so think of the absolute value of 3, says it's going to decrease at a faster rate. So it's looking something like this. It's decreasing at a faster rate. This is this general picture, okay? So now I'm going to go and say, this is the one I think that is the easiest. This is my picture. As I go to the right, so as x's go to positive infinity, do you guys, everybody agree it's going down? So that's how I'm going to first look at this. As x's go to positive infinity, it's not going up, it's going down. It could be this one. No, it's not going up, it's going down. So these are my two choices. Now I'm looking over here. As we approach 1 from the right-hand side, which way is it going? Up. As we approach 0 from the right-hand side, it's also going up. But does anybody, this is important, does anybody know what is going to be the vertical asymptote when we talk about log functions? Is it 1 or is it 0? It's 0. So our correct answer should be here. This should be our correct answer. At 1, real quick by the way, it's not approaching infinity. After it passes 1, after it passes x equals 1, then it goes up. So as it approaches 1, it's probably approaching a value of 0. Does everybody see that? But it's the vertical asymptote that as it approaches the vertical asymptote of 0 from the right-hand side that it's going up towards positive infinity. That's why this is the correct answer. Okay? Let's flip on to the next problem. All right. This is an algebraic one you definitely need to do on paper, but you can do this quickly. Ready, get set, and begin. I can take f of x, and what can I replace with it? Anybody? 3. Now, this is an expanded form. I want to condense this. Notice they have the same log base 2. Okay, I'm good. And what does addition turn into when we condense it? Multiplying. So this is what I have right now. Now, I'm going to write this in exponential form. What form is it currently? It's in log form. Well, what does exponential mean? Some people, by the way, like to write this equals 3 on the other side. It just helps them to view it better. Either way works. It doesn't matter whether it's equals 3 on the left or equals 3 on the right. When you write this in exponential form, you take the base, you raise it to the value on the opposite side of the equal sign, and then you set it equal to whatever's behind the base. In this case, it is x squared minus 2x. I just expanded that. Now, I know 2 times 2 times 2, 3 times is 8. I'm going to move 8 to the opposite side, so there's nothing left on the left-hand side. And when it moves over, it's a negative 8. What does this factor into? X minus 4 and x plus 2. When I set each equal to 0, I get answers of 4 and negative 2. Now, here's the kicker. Are you ready? We need to go back to the original function. Remember that what is behind... Did I do something wrong? Whatever's behind this, when you plug in the values, can never be negative. It has to always be a value that is greater than 0. So when I plug in 4, I'm good. It's still positive. When I plug in 4, 4 minus 2 is still positive. So I like an answer of 4. Anything that has 4, I'm going to circle. Now let's go with negative 2. I'm going to plug in negative 2. Can I have negative 2 in this position? So I cannot have negative 2. That means the only answer is option B. Turn to your partner, making sure you... Problem, I'm trying to find any correlation between this and any one of these. By the way, what's another way to write 8 in terms of exponentials? Nice job. So 2 to the third is equal to 8. Okay? And if I distribute through, what do I end up with? 3x plus 21. Which one do you think is the correct answer? Moving on. So the first thing I want you to recognize is that I'm adding 5 in the bottom. So I'm consistently adding 5, and on top I'm multiplying by 2. So automatically this gives us a function that is logarithmic. So right away I can cancel out these two problems, one being linear, the other being exponential. Okay, now what am I going to do to decide on the answer? I'm going to choose a value. So I'm going to choose an input value of 6. So if I change this to 6, this would give me 1, because 6 raised to what is 6? 1. And 1 times 5 is 5. But it may work over here too. Let's check. So if I, whoops, sorry, this is a 2 here. This is a 2. So I plug in a 6, and I have, okay, 2 raised to the what is 2? 1 times 5 is 5. So that doesn't help me. Let's try now with the 12. Everybody look at this. So if I come to this one, please listen, no talking when I'm talking. I have 5 log base 6 of 12. My input is 12. Now there's a big misconception. I bet you a lot of you think that 6 to the second is 12. Is that true? No, 6 to the second is 36. That doesn't give me a nice answer. Let's try down here. If I plug in 12 here, 12 divided by 3 is 4. 2 to what power is 4? And 2 times 5 is 10. So this one works. I'm going to take this statement right here, and I'm going to write that in exponential form. How do I do that? The base raised to the opposite equals, in this case, equals b. A raised to the fourth equals b. And then I'm going to come over here and write log of, I'm going to write in this position, you know what? I'm going to leave it as a squared. I'm going to take out b, and what does b equal? A to the fourth, and then here's the 3 on the outside. So really I have log of a squared, and behind it is a to the 12th, because when you have a power raised to another power, you multiply. So how do I do this? If I'm going to write this right now in exponential form, I'm saying to myself a squared raised to what value equals a to the 12th. And I just told you that a power raised to a power we multiply. So 2 times what equals 12? The answer is 6. I always think you're going to see a lot of number sense problems like this on the ACT. I always believe that it's easiest to choose a number. What does a have to be greater than? 1. So let's write down a equals 2. Let's just try a equals 2. So if this was the case, let's just take a look at this. If this was the case, And we know here that it's going to be logarithmic. What do we know about the x values? Anybody? What do we know about the x values? They have to be multiplied. So let's try this one. If I tried this, then in this position I would start with a 2. Okay, I'd start with a 2. And then b is going to be 2 plus 2, which is 4. And c is going to be a, which is 2. 2 plus 3, which is 5. And then d is going to be 2 plus 4, which is 6. Is that an example of logarithmic? Why? I'm adding 2, then I'm adding 1. It's not working, right? So I can cancel that out. Let's try the next one. So I'm going to cross this out. I'm going to do it in the same place. I'm going to start with 2. Now b is 2 times a, so 2 times 2 is 4. And c is 2 times a, which is 2, so 3 times 2 is 6. And d is 2 times a, so, 4 times a, which is 4 times 2, which is 8. Am I consistently multiplying by 2? Nope, because 2 times 2 is 4, but 4 times 2 is not 6. Cross it out. Let's try the next one. I start with 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. Am I consistently multiplying by 2? We know it's logarithmic. We now have input values that are being multiplied by a value. Correct answer is D. So let's look up here, please. I want to expand this. So if I expand this, what does division turn into? Division turns into subtraction. So I'm going to start by looking like this. So I like this in the front. I like this. I like this. I cancel out. I've got a 50% chance of getting this right. Now let's talk about how I can rewrite this. This is called change of base. When you rewrite this, I'm able to take and write log of, and I'm going to put a question mark here, log of the back value divided by log of the base. Now this could be any value we want. It could be a 3, a 5, an e, it doesn't matter. So when I look up here, that doesn't look like it. When I look like this, you're like, well, it looks similar. Remember, really, what is ln? ln is what? Log base e. This can be any value you want. So this is the same as ln of x over ln of 4. And this is your correct answer. Once you do change of base, you're able to change that base value to anything you want it to be. If I put these together, does everybody agree this is log base 10 of e times x to the negative 1? Do you guys agree with that? Okay, log base 10 of e, is this happy? No, it goes on the bottom, right? Now what I want you to recognize is that a normal log function looks like this. Normal log function looks like this. But when the x value is on the bottom, so it's 1 over that. In this case, it's the value e over that. What it does is it flips up and it looks like this. It flips up and it looks like this. So is this increasing or decreasing? It is. So a decreasing, so I get to cancel these out. And then is this concave up or concave down? Concave up, we have our correct answer. Again, how is that? How do I know that? This is a normal log function, but when x goes down to the bottom, then we are going to reflect it across this axis, x-axis.